right, so we have a question dealing with a ratio and average. So what we're being told here is that there was a certain number of cans donated, and we're asked to find the average number of cans donated per student. So cans per student, I'm representing as C over S. Now, the average number of cans per student is the same as the total number of cans over the total number of students. And whenever you're averaging a rate or a ratio, I think it's easiest to think of the total number of the top over the total number of the bottom. And we see this with speed, distance, time equations too. Like the average speed is solved by finding the total distance over the total time. So anyways, if we find the total C and we have the total S, we've definitely got the solution. Statement 1 only gives us what C is. So it says there were 56 cans donated, but I don't know anything about how many students there were, so it's clearly insufficient. Statement 2 gives me a relationship, but the relationship is not a ratio. If it were a ratio, I'd be able to solve our fraction here, but instead it's telling me we have C over C plus 40. And I'm asked, what is that equal to? Well, imagine if you put in, let's say you put in 4 for C. We would get 4 over 44, which is equal to 1 over 11. But if C is equal to 40, we'd get 40 over 80, which is equal to 1/2. So I got two different answers out when I plugged in acceptable values for C into my equation. Obviously not using statement 1, I'm just using statement 2 on its own. So statement 2 is insufficient because I can't answer what the average number of cans per student is if I'm getting different numbers out for different C's here. But the two statements together are sufficient because it literally gives me everything. If C is 56, and I know that C is equal to 40 plus S, 40 plus S also equals 56, and S must equal 16, which means our fraction C over S is 56 over 16. And we could simplify that, but it's sufficient. We know it's sufficient. Don't do any more work than you have to do. And I think this is a pretty quick question if you try to tackle it from that high level and just focus on the idea that ratios don't play well with hard numbers. If you have a ratio and you add hard numbers into the ratio, the only situation where you get a predictable outcome is if you add numbers in the same ratio as you originally had. So for example, if I have like a 1x to 4x ratio and I add 1 to this side and 4 to this side, I'm still going to have a 1x to 4x ratio because I've basically got 1x plus 1 versus 4x plus 4. And if we use distribution, that left-hand side becomes 1 times x plus 1, and the right-hand side becomes 4 times x plus 1, and distribution gets us the 4x and the 4 out of that. And you'll notice that we could cancel this and this, and we still have a 1 to 4 ratio. So just a little something to see, but not necessarily applicable here. Our answer here was answer choice C. These two statements together are sufficient.